Hello, fellow humans. Let us try a thought experiment. Does the economy follow the laws of entropy just like living organisms? James Galbraith and Jing Chen seem to think so, as they write in their book Entropy Economics. They developed a mathematical model to prove that is the case. Can mathematics help us understand the economy? We begin with the following premise. Entropy is a measure of scarcity in physics. With this in mind, we can say that an entropy theory of value is a scarcity theory of value. All physical systems tend to move from a less probable state to a more probable state. Entropy is a measure of physical probability at a given time. The tendency of directional movement is what drives, among other things, living organisms. In formal language, systems move from a low entropy state to a high entropy state. This is the second law of thermodynamics, the most universal law of nature. If we go and ask a physicist about entropy, they will say something along these lines. Entropy is often roughly defined as the disorderliness or disorganization of a system. A deck of cards in perfect order has low entropy, while a randomly shuffled deck has high entropy. A low entropy macrostate corresponds to just a small number of possible microstates, whereas a high entropy macrostate corresponds to a large number of possible microstates. Right off the bat, the premise in entropy economics is that if a product is scarce, then its value would be high, which resembles a low entropy. In a graphical form, it would look like this. When scarcity has a high number, it means there's a lot of that thing, so its value is low. And when the scarcity number is low, there's few of that thing, so its value is high. The formula that describes this relationship is this: V of P equals negative log base B of P. V of P is the value, B is, for example, the number of producers, and P is a probability between 0 and 1 that measures scarcity. The minus sign means that the value is a decreasing function of probability or an increasing function of scarcity, which is the same thing. When abundance is very high, meaning P equals 1, and minus log of P equals 0, then the value of a commodity is equal to 0, even if that commodity is very useful. This explains why diamonds are worth more economically than water in many circumstances. The analogy with life systems, according to Galbraith and Chen, is that living organisms have a mission given by Darwinian evolution to decrease the entropy of their organisms in order to live and reproduce. Basically, living systems are mechanisms for reducing the local entropy of their environment. We may also call them microstates if we talk like physicists. But there's a massive problem with mathematical analogies of real life. They use a lot of assumptions, and this is where things get very interesting and significantly more complicated. Karl Marx came up with the formula MCM prime, money, commodities, more money, to describe how the economic system uses the input of money to create commodities, which then are sold on the market to make more money. Profit is represented by M prime. If M prime is not bigger than M, then the owner of capital loses money and is eliminated from the market. This also makes us think of entropy and scarcity, because the number of consumers is limited, and the amount of input money and capital is also limited. It seems that even the quest for profit may appear as a mechanism to reduce entropy by adding human agency over money and resources that are available in the economy. Let us then ask some questions. What if all people involved in the production of stuff were also involved in the decisions pertaining to production? What if the accumulation of profit was limited to a maximum amount? What if property was not so easily converted into capital? What if the incentive to make a profit was phased out? There are massive assumptions that are not discussed in entropy economics, let alone in mainstream economics. When we introduce these assumptions, they come with a huge amount of variables, such as the psychology of all humans involved in production, the culture around accumulation of capital, the rules about the appropriation of natural resources. If we had to enter all these variables into entropy economics, we would get a very complicated mathematical model. Let us imagine that the allocation of capital was not determined by unelected hierarchies, meaning a lot of people would have a say in how capital is allocated. If we assume that each person is driven in life by utility functions, then this means we would have to add up all those utility functions from all those people just by introducing economic democracy. But people are not driven by utility functions. People are not homo economicus. They do not act like rational agents. People live with a wide variety of cognitive biases and irrationality that varies from person to person. We would have to account for all those variables to create a mathematical model to fully account for all behaviors. It would have to be a formula that changes the symbols and variables as you look at it. Derivatives would change into integrals, logarithms into exponentials, products into sums, depending on the dynamic between humans at a given moment. Let us imagine next that private and common land was not appropriated that easily by corporations for the purpose of production. Immediately, land would become a scarce resource in accordance to cultural norms, for example, by respecting the autonomy of indigenous peoples and their commitment to be the stewards of biodiversity. No mathematical formula can capture this, even if we tried really hard. Humans, living systems, and cultures do not know they have to decrease entropy. Nobody has decreasing entropy in their agenda. In fact, there's a long way from the physical laws of entropy to the dynamics of culture. Some cultures are comfortable living in balance within nature and do not seek expansion at all. There's a great book that talks about many examples from history. Next, let us imagine the connection between power and property. Economic models assume that power gives the ability to dispose of property as owners see fit, in proportion to the size of property. If you own 10 hectares of land, you will have power to command 10 hectares. If you own 1 million hectares, you have the power to control 1 million hectares. There's an insidious assumption here about size and proportionality. Power always matches the size of property, regardless of consequences. There's no morality embedded here. It is also because it has always been so. You own 10 million shares in a company, you have 10 million votes. If this relationship was phased out and power over property was limited by some social rules, then the dynamic of the entire economy would change fundamentally. We will no longer talk about being in a capitalist system. These three scenarios is what I call the threefold model of capitalism. These three assumptions are the real-life limitations and causes for the behavior of economic agents. In real life, our economic behavior is restricted by the laws, regulations, rules, norms that are written down in all sorts of documents and contracts. Production and consumption is not caused directly by abstract theories. It is caused by these three doctrines. In the abstract, we can talk a lot about mathematical models, ideology, cultural critique, but all those are descriptive narratives, not causal narratives. I care about the causal narratives, where change actually happens. When some experts like Nate Hagen say that energy powers the world, they actually use metaphors, even if they may not think so. Energy, if left alone, only follows the laws of physics. But a barrel of oil will never jump out of the ground on its own and put itself into your car. People do that using many sophisticated tools and technologies. At the core of economic activity is not energy, but it is humans being caused to behave according to certain rules, laws, and doctrines. When economics gets mathematical, it attempts to describe some of these laws, but it fails all too often. What moves the economy is not some natural law of physics or mathematics, but the action of humans who do not even require free will, but require social agency to act on the available energy. They either move energy around, what is sometimes called flows, or they store it, also known as stocks. Economic models, such as entropy economics, are incomplete and imprecise metaphors for the real life at best. Mathematics is not life. Thank you for watching and supporting me on Patreon. Stay sharp and do not let economists use mathematics to fool you. Economics is about life. Fundamentally, it is not that complicated. Increase the peace.